Question 53, reasonably complicated diagram there, but actually beginning to quite like these, having done them so many times. First thing I'll do is put all the forces on here. We've got some tension in this string here. Tension in this string, pulling it that way. We've got some tension in this string here, pulling it upwards as well. We've got the gravity pulling that down. We could actually figure out what that's going to be in that we've got the masses in there. It's 0.2 and 0.8, which is 1. So we've just got 1g pulling that down here. We've also got the resistance, because this is a rough table and we're told that it's got a resistance of 2 newtons. So we can put all the forces on. Yeah, I know there's some more here, but we really don't worry about those because they're just going to cancel each other out, so they're not going to have any effect on this. But what's happening at P? And look, this is what you're going to be doing lots of times in the questions. At P, pulling it that way, we've got the tension, take away the 2, and that equals the mass times its acceleration. And that's an equation for the motion there. The motion of the pan, well, we've got the G pulling it down and the tension stopping it going down. And that equals the mass times by the acceleration. And if we add those two things together, if we add these two equations together now, then you can see that the t's would cancel out, and I'm going to get g take away 2 equals 1.5a. And so a is, look, 9.8 take away 2 is 7.8. 7.8 divided by 1.5, I can get the acceleration is 5.2 meters per second. And I can figure out what the tension is now just by dropping this back in. Which one? Shall I drop it back in there, shall we? So the tension now is 0.5 times this. That's 2.6. Add the 2. So the tension is 4.6 newtons. Part C. I'm going to draw another little diagram now just to look at this A. So I've got A here and we've got B here. And the forces acting on these things. So the A is 0.2 g pushing down on that. And there's a normal reaction pushing up at that point there. And what's happening to A? Well, we now know A is moving downwards with an acceleration of 5.2 meters per second because we had that earlier on. There's nothing else stopping A. And so the forces on A going downwards are 0.2 g minus the reaction force from there equals the mass times by the acceleration. And working that out, we can then find out that that R value there must be 0.92 newtons. And finally, how do we use the smooth pulley? So the smooth pulley here helps us know that the tension on either side are going to be the same. That this tension here and this tension here are both identical because there's nothing acting here pulling it in any direction or pushing it in any direction. So the statement there is that the tensions in the wire is constant from both sides.